Good morning, everyone. How are we all going? Welcome to week 4 of COMP1511. Big news. Big news this week. Our first assignment has been released, so there's something to think about. I'm out of focus. Hang on. There you go. Back in focus. All good. Yeah, so if you haven't seen it yet, it's on the course website. It's called Slide. It's vaguely based on the idea of 1980s era arcade shooters. This one's kind of a bit like R-Type, if you know R-Type. R-Type's like one of the kind of, I don't know if you'd call it the second or third generation shoot 'em ups when they were horizontal. So it's an interesting thing where we're going to be using arrays to represent a space and something that can kind of shoot into that space and stuff. But I'm not going to talk too much about the assignment because I've dedicated an entire optional but still a stream to it tomorrow. So if you're interested in hearing more about the assignment or even just asking questions about it if you started reading it so far, tomorrow afternoon, roughly 4 to 6 p.m. I mean, I will cut it off at 6 p.m. But if we run out of questions before then, I will stop before then. But knowing me, I can talk for 2 hours with no questions. So we'll hopefully get some information out there. My suggestions for something large like the assignment. So it's what are we thinking about? Like 3 weeks, 3 weeks worth of work, I guess, in this assignment. My suggestion would be read the assignment specification now, even if you have no plans on working on it. Because one of the nice things about the human brain, I guess, is if you just start reading things, your mind will start playing around with the ideas of how to solve problems. And so when you eventually do get to it, it's already been stewing around in your brain and just helping you get a bit of a feel for what it is you're going to do with it when you get there. If people are looking for the live stream stuff, there will be a link in the lectures section, in the week 4 of the lectures section. So I think at the moment I've only put up today's lecture and then the Thursday live stream. There's actually going to be, obviously there's going to be a Friday lecture as per normal. I just haven't actually put it on the website yet. Obviously, assignment release week gets a bit busy for us in the back end as well, so I haven't done all of the prep necessary to get you everything going for that yet. But anyway, so we're ramping up and stuff to do a bit more work than we have been in the lab. So the assignment has more things joined together than just than just the lab exercises. So things lead into each other, and it's a bit more fun because by the end of it you can get a larger project put together. So check it out when you can. The other thing I should say is that don't worry if you don't understand it all right now, because there's content this week that we're going to teach you that will help you understand. I mean, even the basics of the assignment you don't know yet, because I haven't taught you how to expand arrays from this one dimension into a second dimension, which is one of the things we're going to talk about today. Let's go into the slides and we'll start getting to the lecture itself. So, bit of a recap, what we're looking at last week. So over the last week, we introduced, we'd reached a point, I thought, where you were writing enough code that we could start talking about how to start writing code that doesn't confuse ourselves. Because that's one of the big things about programming, is it's a language that humans can understand, but it can be written in a way that the computer still understands, but humans have a lot of trouble with. And the more trouble we make for ourselves with our code, the worse it's going to be for us to actually fix our mistakes or to be able to show someone else our code and have them understand it. So we do need to put a conscious effort into making our code human understandable. And we looked at both code style and code reviews as techniques we can use to try to keep that going, in a sense. We looked at functions as well, which was how we were going to write a separate piece of code that could be jumped into, run, and then you jump back to where you were running previously. So functions are very, very useful for that kind of thing. not only do they allow us to separate code based on what it is doing, that allows us to call the same code multiple times if we need to. We also looked at arrays, which was our way of saying, instead of having individual variables, we can have variables in collections. And these collections are put together very, very similarly to the way that while loops run. So they're made for us to be able to loop across the entire collection and see everything in it. So that's going to be a very powerful thing. I mean, people really get into the idea of analyzing a lot of data. And this is the very, very basic level of analyzing a collection of data, is to be able to look at every element inside an array. So you think about, like, you know, it's huge at the moment nowadays, talking about big data analysis and stuff like that. This isn't exactly the same, but I mean, it's really like the first step on the way towards those kinds of things. Okay, so today what we're doing is basically we're doing an extension on what we had started learning about functions and arrays. So we're not necessarily introducing new content today, but we're going to expand both of these things. So we'll look back at functions a little bit, and we're going to look at libraries. So we've actually been using these for a while, but I haven't fully explained what they are or how they work. So we're going to look at what a library is in C, and how we can use functions that aren't necessarily written in our own files, but might be from other files. So we've actually seen this with printf and scanf, but we'll talk about that in a sec. We're also going to talk about an expansion on arrays. So it's really just kind of continuing on these two things, functions and arrays, but then adding a little bit to both. So we get this idea that we can put an array inside another array. And I'll talk about that more, but being able to put arrays inside arrays allows us to build grids and cubes, and if you really want to, you can go into more dimensions than that if you want your brain to explode. But we're gonna look at that. We're going to stick to 2 dimensions. We're not even going to go to 3-dimensional arrays in 1511. I figure 2-dimensional arrays is going to be hard enough as it is. A lot that's in this lecture should hopefully be quite helpful to people, because the 2D arrays form a part of what's in the first assignment. So a lot of people, I think, will not be starting the first assignment until after today's lecture, which is totally fine, by the way. Like, we considered the assignment to be kind of, as it was released on Monday, was it Monday? It may have been Tuesday, because it was released really close to midnight on Monday. Anyway, you could look at it then, but a lot of the stuff we're covering this week is very, very helpful for actually getting it done. Okay, so a bit of a recap on functions. Tom's like, it was Monday. It was only just, and it was like 11 p.m. or something around. It wasn't actually that late on Monday. 23:55 was it? Okay. Anyway, recap of functions. So thinking about just the basics of what a function is. One of the subtleties that we're going to get to with functions is deciding when and how to use them. So my suggestion when you're starting out with functions is just to use them heaps. Like, just use them for, like, everything until you get a nuance for, like, okay, this is where it really makes sense to pull something out of our main function. We get a lot of the time where the main function in a program is really, really short. So it's really short and really really small, and all it is a series of function calls, and then all of the code is actually pulled out of the main and put into separate functions, so that you know that everything's sort of categorized by what it does. That is like this kind of holy grail of programming with functions, and we may be able to get there with some of the things that we're doing in 1511, but we'll show you as we go along. I mean, maybe I'll try to do something like that today, where it's actually really, really function based. And the main function is really easy to read because it's just like English words, one after the other. But anyway, function, it always has a name, and that's the name we use to call it when we want it to run. It will have inputs and outputs, as in information that goes into the function and information that comes back out of the function. We've got to keep these separate from the idea of printf and scanf. So we consider those being inputs and outputs to and from a person. The function's actually talking to the rest of the program when we're talking about its inputs and outputs. Both of those are optional. You can have a function with no inputs, you can have a function with no outputs as well. We talked about the void keyword when we were talking about that last week. The return keyword now has kind of more meaning than it did previously. When we only had one function, and it was the main function, return was going to end the function. Return still ends whichever function it's in, but now that we think about passing information to and from functions, we know that the return keyword is something that gives back information to the rest of the program. So, basic idea of functions here. I think this is potentially exactly the same example that I used in the function lectures. So we've got our main here, and the main gets to this point and it calls the add function. The only reason it can call the add function is that it knows, it's been told previously what the inputs and outputs for the add are. So when it gets here, it goes, oh, I know this thing is an integer type function, which means its result can be stored in an integer, which is just a standard equals variable assignment that we're doing here. And we know that it takes in two integers. It's going to call them A and B, but we don't have to call them A and B here. So when we're giving information to the function, we can give that information based on the information that we have in our main here. And so it'll take number 4 here, number 6 here, and put them into this function. So when this runs, it'll go looking through the code for the actual definition that we call of the function here that will then do its own setup. So it'll start this line and it'll say, okay, I've got an integer A and an integer B, and I've been given this first number and second number, so that I'm going to set up these variables. This is actually like creation of these variables, where A will be created and initialized with the value 4, B will be created and initialized with the value 6. A and B are not related to first number and second number. They have the same values as them, but there's no connection between those two, other than the fact that the 4 and the 6 from these were given to this function. So they're separate variables, and each one is within their own set of curly brackets. We do some work in the function here, and often functions can be longer. Usually functions are longer than one line. But when we finish doing the work, we'll give back something. So this return gives back A plus B, and in a sense, this return will be this integer, which will then replace this function call here with whatever number was returned. So in this case, oops, clicked on it by accident. In this case, it'll be 10. And so this will be replaced by 10. Total will have 10 assigned to it, right? So the information going in and out of the functions will work in that pattern, right? When we reach the function, we will give information to the function will create its own variables based on that, and when the function returns, it will basically transform itself into whatever variable type the function was, and then it can be used in the main, or even in another function. We can have functions calling functions. So, I think, someone just hopped up on the desk to say hi. I think we've talked a little bit about this already, but the nuance in using functions is knowing why they exist and what we're going to do with them. So one of the things that's really handy with functions is if we're going to use the same bit of code multiple times, it's much better to put it in a function and call the function multiple times than it is to copy paste the code. The other thing about that is if we had copy pasted code, we'd be in a situation where anytime we wanted to make changes in the code, we would have to go through and find every place we'd copy pasted that code and make changes to it. The function means there's only ever one place that code is written. So that's one thing that makes functions really, really handy, is you're just writing less code and there's less chance you're going to have to make any changes or anything like that. Also means that your code is categorized in a way so that if you've got stuff that's doing a particular task, you can just give the name of the function that task, and then the complicated code is kind of hidden away, so people only have to look at it if they go really, really deep into the function itself. Everybody's noticed the Blackpink t-shirt. So what this does, sorry, I'm just getting thrown off by the fact I am wearing K-pop merch. This allows us, in a sense, to both put our code into little separate blocks, in a sense, that we can use, as well as control exactly when our code is used and not have to write as much. So functions are really useful like that. But in general, it is going to take a while for people to understand when and where to use functions. So that's something that it comes down to for a while, that you'll be writing code in your main and you won't know whether chunks of your main code could be put into a function or not. The way I like to think about these kinds of things is that, what was I going to say? That the functions you can nearly think of as, like, in your head, okay, do this task or do this other task and stuff. And when you think about a task or something that you want your program to do, you can actually separate your program into functions that cover those actual tasks. So there's some cool stuff like that, it takes a while to get a handle on, but once you get there, it's pretty good. Okay, so I want to talk a bit about C libraries. Now, we've actually been using one of the C standard libraries heaps, and that's what we've been doing with our includes in nearly every program that we've been writing, is we've been using this one called standard input output, the stdio.h library that we've been using heaps. That is not the only library that C comes packaged with. We don't necessarily use all the libraries all the time, and that's why we use the hash include to just pick a library out one at a time. So there are a few more, and I'm going to show you a couple of them today, but we're not going to go super deep into them yet. Later on, you will end up going deep into them. But the C libraries have a whole lot of functions that are what we would consider to be the commonly used functions in C. So standard input output has stuff like printf and scanf that we're going to be using heaps. And there are other ones like math.h, which has a whole bunch of maths functions. I think math.h is well known as being the library that has, like, I think every function is, I'm not going to be 100% on this, but I think nearly every function in math.h is a double function. So it has all these capabilities of working with floating point numbers and things. And then there's the standard library.h, which we will get to the point where we will start including the standard library.h in pretty much every program that we're doing. It has a lot of just generically useful functions. We're actually going to get into that more later. So if you need to, you can actually look up C references. If anyone's been doing our revision tests so far, which is just ways for you to just sort of see where you're up to in the course, I think we've only released one of them, which is the revision from the first few weeks. So hopefully that one is easy because it's only got information from week 1, I think, in it. The revision tests have a cheat sheet which has a basic look at some of the standard libraries and how they work. There's also ways to look at references. There's actually a command called man in Linux. It's not about a person. It's short for manuals, and you can actually type in man and some of these C libraries and even some C functions, and it will actually give you information about them. You can also Google these things. So one warning I should put in is if you go looking into documentation about C libraries and stuff, just be careful, because there's going to be hundreds of functions in these, and heaps of them we don't know about, and heaps of them you don't even have context for what they even mean. So don't worry about it too much yet. As always, like, what have we've only been doing this for 3 weeks, so strangely enough, there's a lot of C you don't know yet, and we'll get there eventually. So showing you some libraries and how we might use them. It is interesting to see that This line here, we already know about. We can hash include multiple files. Sorry, chat's been moving pretty quickly, but I think that Michael is on top of that as far as I can see. Yeah. Okay, so any of the C standard libraries, we can do a hash include to use them in our code, which means there's a lot of freebies in there that we could use. I remember when we were talking about, which one was it? The dice checker, the second dice checker, when we were talking about mods sometimes giving us a negative result and things like that, and us ending up with a situation where we have to flip a negative number positive. And we did a little maths to make that happen, but you can actually do that with this function here, which is the absolute value function. From memory, it's funny because it's a mathematical operator, but it's I think it's actually in the standard library, not in the math.h library. But the math.h library can do other things, like it has this function for square root, because manually doing a square root is like super annoying and quite difficult to code. So it's really nice to have someone else having done it for you, and you just go, okay, square root this number, and then we'll store the result somewhere else. So in the same way that we've been using things like printf and scanf, we can use other functions that are in these standard libraries. So a lot of the time when you're looking for the capability to do something in C, so you say, oh, I would like to be able to do a particular thing in C, you could actually Google this and go, oh, how do I do an absolute value in C? And then you'll probably get information saying, did you know that the standard library has a function to do this already? And you go, oh, that's great, because then I don't have to write code for it. I can use the standard library code, and one of the nice things about standard library code is it's already been used by, I don't know, I'm just ballpark numbers here, like hundreds of thousands of people have already used these things. So you kind of have a reasonable reliance on the fact that so many people have tried and tested these things in different situations that it's unlikely to go wrong for you. You can see I'm always really cagey about this stuff. I'm just like, I'm never going to say this will always 100% work, because it's still written by humans, and code written by humans is fallible. You know, we always know we make mistakes, and so it's a matter of us testing things to make sure things are working. But we're reasonably sure that these functions have been used by so many people that there's not likely to be massive errors in them, as opposed to your own code and my own code. When we write it, we're like, yeah, I'm pretty sure there are massive errors in this, and I know that this is going to be a process of me fixing those errors before I'm totally happy with them. So always like that. But the standard library functions, you can have a reasonable amount of trust in them. As we go further in, we're actually going to look at writing our own library stuff, our own separate files that we're going to use, but we'll get into that later. Okay, so one thing that I think, do I have a slide on this? Yeah, I think I was going to look at the inputs and outputs of stuff like scanf and show you that, because that's actually going to come up in the assignment as well. You may notice that everything that I'm teaching you today is stuff that's useful for the assignment, so hopefully that's handy for people. We're going to be using libraries to do memory management, and that's actually going to be later on this week. We're actually going to start digging into the memory of our computer and playing with it. But printf and scanf are things you've already been using. So let me show you one thing that we can do with the output of functions. Sorry, I just need to push my camera feed out of the way of the text there. So functions are going to return the result of what they ran. So when they have their return keyword, they're going to say, okay, this is the information I'm giving back. So like any C expression, once the expression is like run or evaluated or something, like if we do A plus B somewhere, like C, when it reads, is going to say, okay, I'm going to take the values of these two things, I'm going to add them up. And that's what that whole section of code is going to be. A function's like that as well. We're going to run the function, and when it's finished, we're not going to see a function anymore, in a sense. We're going to have whatever value the function spat back out when it called return. So if we look at scanf as an example, this is a function we've used already, but we've never actually used the output of the function. We were just using it for its side effects, which is the fact that it can read some information in, and that information will be written directly into a into a variable. But scanf actually has a return. So the return, the integer that scanf returns, tells you how many things the scanf has read in successfully. So we can actually use that to do some interesting stuff. So I actually have the scanf demo, which I will... Oops. Sorry, I was on the wrong window. Let's log in. Let's log in very slowly. Let's log out and try logging in again. That was a bit weird. Okay, good. Scary for a second there. I love how the joke of anytime something goes wrong with a computer, you just turn it off and on again. That's exactly what I did there. I was like, I'm not sure what's happening with that particular VLab server, so I just relogged in and got a different one. We are in lecture 7, and I have this scanf demo. So there's a lot of code in here, and I'll let you see the code and stuff. I'm going to talk a little bit about it, but I'm not going to write all of this stuff from scratch. But I'll show you a little bit. Oh, VLab is being a bit of a slowpoke today. I wonder if... I don't know if anyone's noticed, but I've just upped my stream bitrate because I realized I wasn't streaming at 1080p, so maybe I'm killing my upstream, which is slowing down VLab. I'll fix that later. Okay, so if I wanted to scan in 10 numbers, I could actually use the output of scanf to decide how many things that I'd inputted. So scanf is going to tell me how many objects it read in correctly. So I'm going to say objects, not numbers, because it's not always numbers, right? I could do a %d or a %lf, and there'd be different kinds of numbers. And it's going to put them into this array. And every time it reads something successfully into the array, the count, so how many numbers I've read in, this number count thing goes up by 1. So we can do this kind of thing where we can say only if a number was read in successfully does this count increase, and then you keep going until you've read in 10 numbers. I do have a little Easter egg in here, is like, see if you can find the issues this causes. There are ways to make this break, so it may not be the best way of doing things. There are other ways to scan in 10 numbers, so I could do it like this. This is a very, very sort of blind, brute force way of doing this, where we just do everything really explicitly. Yes, this does work, but if someone said, oh, okay, 10 numbers worked, great, can you do this for 100? Somewhere through the typing of all of these up to 100, you're probably going to get very, very tired of the code that you're writing and be like, there's got to be a better way of doing this. So usually I would consider a looping option to be better than typing it all out. But I thought I'd show you because this definitely works. And it is interesting to note that when it's looking for numbers, scanf will ignore white space in between. So if you type in numbers with spaces in between, this thing will still work. There are also ways that we can do things where we can say, let's keep looping until we've received a particular set of numbers, or until the user actually says, I would like to stop reading in numbers now. And so there's a particular thing that's going to come up a bit. We're going to learn about this in your tutes and labs as well. I think it's this week. Oh wait, this week or next week? It might be next week because I'm showing it this week, but I'm not sure. So we can press Control D at the end of our input when we're typing something in, and then that will send a signal to our program that is known as end of file. It's not really used that much for typing in, but it's called end of file because it's usually the thing that says, oh, I'm reading stuff in from a file on my computer or from a network connection or something, and it's the thing that says, okay, the message has ended. We can do this with Control D. So what this now means is I can make a loop that goes forever and just keeps taking numbers in and storing them, although in this instance we are still going to stop at 10, but I can get it to stop at some point by saying, okay, I'm finished here, and I can send a Control D to the command line here. And the way that we're dealing with this is we're using this result. So I can scan in a number, so I don't even need to worry about where this is being stored or anything. If I scan in a number into result, and I can say, check if result is 1 or not. Because if result is 1, then we've read a number in successfully. If the result is not 1, then we have some kind of invalid input, which means maybe someone typed some letters in, or someone pressed Control D and says this thing is finished, which means that scanf didn't get any more numbers. The result was not equal to 1. We flip this keep looping from 1 to 0. Now this is that same kind of thing that I was talking about when we were making loops. This is actually combining our two types of loops together into one. So it has one loop that goes up to 10, but it has this other thing which was our sentinel variable in a loop that said that if this thing changes, we're not going to keep looping. So I've just said, if we didn't get a valid value, we will no longer receive any more values. So it's like, that's it, we're done. And then the loop will get around to here, keep looping will be 0 here, and so the while loop will stop running. So what we can do then is we can have this kind of code that says, keep taking inputs until the input is either invalid or finished, because both Control D or an invalid input are gonna make this scanf not equal 1, because it won't have read a number in. And then when it's not equal to 1, the result of the scanf is not equal to 1, we turn off the loop. So it's a nice little, in fact, I'm gonna comment out some of this and we'll run this and I'll show you how this is working. I'm gonna keep this bit here. So, what this is going to do, what this bit of code is going to do when I run it, it's going to ask me to enter 10 numbers and press Control D when I'm finished. So I'll enter a few and I'll press Control D, and then after that's finished, this should print out all of the numbers that I've stored in this array. So let's compile that. Scanf demo. Make sure everything is... A lot of people asking about the code there. Hopefully Michael is explaining everything to everyone. Eric's asking if scanf always returns 1 if it receives a valid value. Scanf actually... let me show you how you can find out this information. Scanf in C. I know this one. C library function int scanf reads format input from standard in. Following is the declaration, so we know we can do that. Parameters. Input return value. On success, the function returns the number of items of the argument list successfully read. If a reading error happens or the end of file is reached while reading, the proper indicator is set. And if either happens before any data could successfully be read, EOF is returned. EOF is that thing I was talking about, end of file. All we need to know is that EOF won't be one of the numbers that we get. So this is the kind of thing that we can read if we want to. Like, some of this stuff is a bit confusing, but a lot of it, you can get a lot of information out of it, which is saying that the function, the key bit of here is the function returns the number of the items of the argument list successfully read. This makes it very easy if you're only reading one number at a time. So it'll give you a 1 if it's correct, and it'll give you some other result if it's not correct. So this is why I'm checking just for the correct result here. This one, with its 10 numbers, commented out at the moment, but this one with its 10 numbers would give us a 10 if it had run correctly. Okay, so let's compile this and run it. So please enter up to 10 numbers, Control D if I'm finished. So just to make it easier, we can see what's going on. I'm going to enter 1, 2, 3. Show you how it scanf is going to deal with enter keys and white space as if they kind of don't exist. Now I'm going to press Control D. Control D is going to finish my input. And this is the stuff that got put into the array. So I got my 6 put into the array. Obviously the array has been initialized as all zeros. Where did we create it? Here. Actually don't need that 0 for that. But yeah. Sometimes I put the 0 in there to remind myself it's going to be all zeros. But yeah. So that was scanf saying, I'm going to keep looping and taking your input in. Well, not scanf. My program using scanf was just going to keep looping. But the only time it was going to stop looping is where we didn't give it a number. So when we didn't give it a number was when I pressed Control D. There are other ways that this thing could stop. So say I do something like this. My scanf has said, you typed in a thing that is really not one of the things I'm looking for. So I tried to read a number. You gave me letters. That is not going to give us a 1 because when that scanf ran on those letters, it was not able to read a number, so it didn't put a number in. And so this ends this loop here. So a lot of people were asking, I think, when we were very early on, like in week 1 and 2, looking at reading in those dice numbers and stuff and saying, okay, what would happen if we didn't do that? This is the reason why I didn't teach you that earlier. Because it's really about like, scanf is a function, and a function's going to return a value. And if it returns a different value, we need to check it differently. And really, this works well when we're looping. And so obviously in week 2, I was like, I'm not going to teach you that yet. There's too much other stuff going on. But now you can do something that actually uses scanf and rejects the import that isn't correct, or knows that it can end the input when it's told the input's going to end. So hopefully this scanf demo here will come in handy. I'm going to get rid of the comments so that all of the code has its syntax highlighting. Another thing that we can do if you want to take this to the next level, this is slightly challenge territory, is your while loop can actually have a function in its condition. So in the question that we ask, when we ask, does this while loop keep running, we can actually put a function in that question. So the question will always be asked. The scanf function here will always try to run, but then it will be converting it into like a 1 or a 0 response here by saying, was this thing equal to 1? So if scanf was equal to 1, as in, did we read in exactly one number from this scanf? It's the same thing as this kind of check, but it's like slightly inverted. So if we did read a number in, then the number of the count of our numbers that we've done goes up by 1, but also the scanf function here has run and it's put a number into the array. So this is a way we can actually add on to things where we can say the question in the scanf could actually be an entire function if we wanted to. You can get really complex in these things if you need. But this is a way to get a little bit even trickier than this. Functionally, it's really the same code as this, because it's going to run scanf, it's going to check the result, and then the loop is only going to keep going if that result was correct. This thing, it's actually checking that result before it gets into the loop, and you'll only get into the loop if that result was correct. So they're both doing the same thing, where they're going to read in a certain number of numbers, but then stop if either the user says, I have nothing more to give you, or the user makes a mistake and says, I give you invalid input. The program's like, I can't continue with that, you know? So this is the very, very short version of this. This is probably easier to understand because you can read it line by line. But if you want to, you can get to the point where you start putting trickier things into your while loop questions. Anyway, I just wanted to show you that. I'll save that again so that's still in there. You can play around with this code. Some of this code is going to come in very, very handy in the first assignment. I will often, by the way, if you use code from the lectures or the labs or the tutorials in your assignment, that is that is totally fine. You can do that if you want to, right? So if you need to use code like this to read in multiple things, you can. Bear in mind that I have written this specifically, and I know how the assignment works. You can't just copy-paste this in and expect it to work. It won't just work like that. But a lot of the theory of what you're learning in demos like this will work very well in the assignment. People asking about... Oh, I think people are talking about EOF and stuff like that. I'll let Michael answer those questions. Don't want to get too deep into discussion of things that we probably don't have time for in the lecture. Okay, so hopefully that scanf demo shows you a lot of interesting stuff that can help with working with the output of functions, but scanf is a particular one where it's the kind of function we often want to keep looping until we hit a certain point and then we stop. So hopefully that demo code helps you out there. Okay, so another thing that we've been looking at recently are arrays. So we should do a quick recap of that and then we'll go a bit deeper. So arrays contain multiple variables of the same type. So we have an array. It's a chunk of memory. So there's a chunk of memory for each individual variable. But an array is a variable that contains enough memory for multiple of the same type. So this is an integer array, I think. It's not defined anyway, but we will be storing multiple integers in it. And each of them doesn't have its own variable name. The array will have a variable name. And then each individual element, as we'll call them in the array, is accessed via its index in the array. And the index is basically how far away is this number from the beginning of the array. So the thing at the start of the array is 0 away, and then the number one element is one element from the beginning. That's the way you can think of the indexes. This is also going to be the numbers that we would use to loop over the array. We've got some detail here. I decided this time around to use doubles, not integers, because I think I've used integers in pretty much every example I've done so far. But it's good to remember that an array doesn't care about what variable types it's holding. It does care. That's the things it's holding, but you can make an array that holds any other kinds of variables, right? So we've got integers and doubles as our types of variables, and you can obviously make arrays with either one of those. So I make a simple array here. They're all going to be 0 at the beginning, and I can assign a value. So just remember, square brackets are the symbol of the array. So when an array is being created, the square brackets are used to decide how big the array is. After the array has been created, the square brackets are used to access individual elements in the array. So even though this word here and this word here look very similar, they're different because this one is an initialization, and you can tell because it says this is the type that I'm making something of. Afterwards, when you're just using it, the square brackets mean I want to access an individual part of it. If we want to, we can test the values in the array. So anytime we're accessing one element of an array, it will act exactly the same as an individual variable of the type that the array stores. When we want to access multiple variables in an array, I've talked about this a fair bit, that a loop is perfect for this. So loops starting at 0 and going until less than the size of the array are always going to go through and look at every element in the array. There's going to be plenty of times that we need to look through every element of an array, and I think this is going to be sort of the basic core understanding of how we're going to work with arrays most of the time. If we're looking for something in an array, or we're trying to get the total of the elements in the array or anything like that, we're just going to loop through the array, and then based on the information we see there, we're going to do something. So this standard while loop through an array, I mean, it's not, the printf is not the standard bit of it, but the access of the I element inside the array is something that I think everyone should get pretty used to, because it's the kind of thing you're going to use a lot. I did want to talk about one other detail about arrays, is that you may have, I don't know if people have done other programming and stuff like that, seen other things where you can actually change the size of a collection of things. Arrays in C don't do that. So arrays are very, very fixed in size, and they're fixed when the program starts running, and they will only do that size. So when I declare this array of size 4, you remember that memory diagram. I won't jump back. I'll have to go find the slides to jump back. But that memory diagram of like, okay, here's your code and here are the declared variables and stuff like that. The array is one of those variables. So when the program starts running, it gets a specific amount of memory for each array, which means that we can't do this. I can't say, here's my array size here as a variable. So a number that doesn't have a fixed value, I can't then create an array of that size because I can't be sure that this is always going to be the same size, and this memory is assigned when the program starts running. If while I'm in development, I would like to maybe change the size of my array, so this is changing it while I'm editing my code, not changing it while the program is running, I can actually do that. So I can use a constant for my array size. So I could, this is a very poorly named constant, by the way. Like this would usually have some kind of meaning, but in this case it's sort of alright. So I could say this array size is 4, and then I can use this in here. Because I've guaranteed, because this is a constant, this number's not going to change. So this is fine. It will be able to declare at this size. But a variable wouldn't work. I can't use a variable as the size of the array. So sometimes, and I think we did this with a number of players in the demo for that the game scores. I think it was called Score Tracker that we did last week, where I said num players is equal to 4, but then that could potentially change later on. So this doesn't necessarily give us an array that can be changed in size, but it means like if we're working on this project and then partway through we're like, oh, actually I need this thing to be bigger or smaller, I can just change this one number. And then everywhere where I'm using these arrays or anything in there, the number will change. So the constants will make it a bit easier, but I think the thing that I wanted to point out is that we can't just have an array that gets created on the fly like this based on this particular size. It's going to have to be set up in advance. There are other ways to do it, but we'll talk about them later. But yeah, I think the thing that's important to learn is that arrays are kind of, you can think of them as being created when the program starts. They're not necessarily accessible when the program starts. They have to be declared with a name and stuff. But once the program starts, it's already decided how big all the arrays are going to be. Okay. I'll put myself out of the way of the meme for the moment. So, I have said that an array is a variable. It's a variable that may contain other variables, but it is a variable. And I've said, yes, an array is a variable. An array can contain variables, which means you can put arrays inside arrays. Am I doing the face right? Hang on. Yeah, there we go. Yeah. So, what we get with this situation is, if I can put arrays inside other arrays, that means for every element in an array, if I have an array, I can quickly multiply the amount of things that I've got inside an array. So, if I have an array of size 10, and then I have it, instead of storing individual elements, I have it storing other arrays that are also size 10. Suddenly this 10 arrays, each with 10 elements in it, goes up to 100 elements. And if each of those elements that's stored in that is 10, then you've got like more and more and more, right? Eventually, the thing that we're going to store, eventually in the end of it, does have to be some kind of actual variable type. But we can do these multiple dimensional arrays. So the thing that I like to think about this is an array is a row of elements. And then if I have an array of those arrays, I can have columns and rows, and I can have multiple rows in it. So we're getting towards the fact that we could build a grid, or we could build a cube of like integers or something. And then we can go to more dimensions than that, but I'm going to stop at 3 because I think 3 dimensions is a reasonable place for humans to be able to think about something, because we live in a 3-dimensional world. Once you get into 4 dimensions, then you're like, okay, yes, theoretical mathematicians totally fine with this kind of thing. Computer scientists partially maybe okay with this kind of thing, but human thinking starts to get a bit twisted when we start to add too many dimensions to things. So I'll get my head out of the way there. So this is a way that we can think of 2-dimensional arrays. So you can think of them like a grid, and you can think of each of the indexes being used as like a coordinate to reach a particular square in this grid. And this is the way that we're going to be using these things in the first assignment as well. So you're going to get plenty of practice with these. So we can think of as this array here has 3 elements in it. Each element in this array is an array of integers. And these arrays of integers have 5 elements in them. So if I go into this array, into element 1 of this array, then I can see these. So I go to element 1 of this array and element 2 of that array, then I get down to the number 91. So this setup allows us to store a great amount of information under 2 different indexes. There are some rules, though. The way that we're going to be using these, and there are fiddly ways to do this, but the way that we're going to be using these is reasonably simple, in that this array, everything in this array, each element of this array, is always going to be an array of the same type. So in the same way that, like, when I created an array of integers, every integer inside that array was the same type. It was a 32-bit integer. So when I create this array of 3 arrays, each one of those is the same type. So each one of these is an integer array of size 5. And you can define that when you create it. So, some code for this. And it's not too hard for us to use because it has a kind of a shorthand. I can say, make me a grid of size 4 by 4, and I can initialize all of zeros in the beginning. So this grid of 4 by 4 says that I have an array of 4 elements, and each element inside that array is an array of 4 elements, and those elements are integers. So I can say I've got a 4 by 4 integer grid, and it's going to look a bit like this. This is a 3 by 5, but anyway. And then we can think of this as being a 2-dimensional grid of elements that we're going to be doing things like assigning values, testing values, and stuff. So if we want those integer values, then we're going to need to give it 2 coordinates, so it can go, all right, I go down these coordinates, and then I go across these coordinates, and then I hit a certain point. We draw them in this particular way with 0, 0 in the top left, because this is the way that if we print them out, this is going to work. So if we are going to do a loop to print these out, I would loop starting at 0, and I'd loop through these, going 0, 1, 2, 3, 4. And then I'd go down to 1, and then I'd go 0, 1, 2, 3, 4. And then I'd go down to 2, and 0, 1, 2, 3, 4. So we think of them in this order because this is the way we're going to be printing them out with loops. If you're doing maths, we would very rarely be starting with 0, 0 on the top left corner of our graph, and then having zeros, having this index count downwards instead of upwards. Like usually the positive and the y-axis goes upwards in basic maths, but we're going to do it this way because it's the way we print it out. So it's going to be much easier for us to think about how we work with this thing as a data structure with loops and stuff like that, if we count downwards like that. Also, if we're going to go really, really kind of historical about this, this is the way that our computer monitors display things. So they start in the top left corner, and they go across, and they go down to the next line, and they go across, and they go across, and that's how the pixels actually change color in a sequence like that. It's really, really old school. It's based on old cathode ray monitors, and like TVs and monitors used to be like that, where they'd actually have a beam of light that would come and hit the front of the screen and illuminate things, and they'd have magnets that would just move that beam across, and that was the sequence it used to do. It would do the top line from left to right, then the next line from left to right, and so on all the way down. And so a lot of that kind of legacy is still in our computing, where anytime we're using two-dimensional things, we're usually going to be starting at the top left and we're going row by row as we go down it. So your while loops are going to be doing that same thing over stuff like these 2D grids. Okay, so we'll take a break there. This is one of the funniest GIFs that I've got. I always like to show this to people because it's hilariously triggering. So we're going to take a break. And I want to talk about problems. Because we're going to hit a point now where we're getting many more problems than we would have had before. And especially when we're going into an assignment now, you're going to find situations where it feels like this. Wait, where am I now? Where I've moved my camera. It's going to feel like this. It's going to feel like things just don't work no matter how, no matter what you do and stuff. And it's just more and more frustrating. So I just want to remind everyone that every big problem is usually made up of small problems. And it's a matter of trying to find your way around those little problems and trying to see if you can break down problems into little bits, and so you can work with self-contained pieces that are like easy lab exercises rather than trying to think of a gargantuan project the size of doing an entire assignment all at once. So yeah, so this is this has always been really funny when I show this GIF in person, because the physical responses, the noises that I hear in the lecture theatre when I show this is always really funny. This is an art piece, so this has been in playing in galleries, and I can imagine what that would do to people. But anyway, let's take 5 minutes break. We come back. I want to show you both use of functions as well as 2D arrays in an example we're going to do. So it's 11:57 now. We'll come back at exactly 12:02. I am tempted to leave this GIF running for the entire break. No, I won't do that. That's too mean. It's already looped more than once now, so I'll go into break mode now, and we'll be back in a sec. All right, I'm back, and the GIF is back as well. All right. Let's move on from the pain. But you know, you all signed up for a programming course, right? This should have been what you were expecting. As someone that's been programming for several decades, this is now funny. It's not painful anymore. I don't want to discourage people from programming, but solving frustrating problems is like one of the things that defines programming, I think. But the reward when a problem has been very, very frustrating, the reward when you complete it is a big deal. So it's something that I think that will sit with a lot of people when you do start to be able to solve these things, or when you look back at this moment, when you go, oh, this was when the first assignment was released and I had no idea how to do it. Some of you are going to be able to look back in a few years' time and go, I remember thinking that stuff was hard. And I remember Mark joking about this kind of thing, but now I have much more difficult problems that are very frustrating. But at least it means the older problems are less frustrating. So hopefully that's where we all get to. Okay, so I'm going to do some coding now. We're going to code a simple game that I call the tourist. So we're going to have a world that the tourist is traveling around on. So I find this. I made this example before COVID, and I find it now a little bit ironic and a little bit sad because we can't travel. So the tourist is traveling, but maybe the tourist is traveling just in an area around their own city that they're in. I mean, I don't know where everyone is in the world, but some of you are probably in places in the world where you can't even travel around multiple cities or anything like that. So hopefully I'm not being too mean by using an example like this. But what we're thinking about is a two-dimensional space. And so the world is a two-dimensional square grid space, and there's a tourist that is somewhere in this space. They can move up, down, left, or right in this space, and we want to be able to show this particular world, including where the tourist is, and we also want to get into this concept that the tourist likes seeing different things. So every time they walk somewhere, we're going to say the tourist has already been there, and then we're going to say this game will be lost if the tourist goes back where it was before, and they accidentally go where they were before. So people in chat are laughing that I'm saying that the world is flat. Look, in computer games, the world is nearly always flat. If we want to do this spherical, then I'm going to have to teach you some significantly more difficult programming stuff before we can get to moving around on a spherical surface. So we're not going a real world situation here. We're talking about a virtual world here, and nearly all virtual worlds that we play around with are actually dead flat. Like nearly all computer games are on a flat plane, and then there's stuff built on them, right? So I don't even know why I got into that conversation. Yeah, it's a Minecraft world. It's square and it's flat. Actually, no, Minecraft is a cubic world. I'm going to move on before I can get deeper into this conversation. So we're going to have some starter code this time, and I wanted to do some starter code because you've been given some starter code with your assignment. If you haven't looked at the starter code yet, it's worth looking at because you can see some of the stuff about the layout, and it actually helps you getting started because it tells you where to put things. The starter code that I've got here, I'm going to close the scanf demo because I don't need that for the moment, is called tourist.c. So you can see this in one moment. We're in lecture 7. I'm going to put that in the YouTube chat there. If you're not on YouTube and you're watching this after the fact, you can also just follow that web address to the code. So this is the live code. If you're watching it after the fact, you'll get the result of the code. But I think I put the starter code in the lecture section on the website anyway. I always have to remember that not everyone's watching this like exactly as it happens. But if you are live, then you can just watch my code as it is edited. Okay, so here, and this is... I actually put more than one date in this because I realized this is one of my oldest examples that has survived through many iterations of COMP1511. So, first created in June 2019, but I edited it the other day for this. So, this starter code is actually very, very similar to the starter code that you get for the assignment, where it had some dimensions for the map itself. I think that the starter code for the assignment may only have one dimension, and that's the same because it's always going to be a square world. But it also has this function that prints the map, and it has a main function. At the moment, there's nothing in the main function, so it's not that much in it, but this is one function that we can see this, and this is how you can think of the functions, right? It does one specific job, so it prints out the map, and we're probably going to use it multiple times. So this thing is going to loop through the rows and the columns of the map. So we're calling these rows and columns to make it a little bit easier for us to understand where we're going with these things. So we're going to loop through the rows. So if we have, one second, we're going to get more visual. The more complex our concepts are getting, the more visual I'll end up getting in the slides and the lectures. I'm going to make this reasonably small to begin with, so it's just easy to see. I should have left myself enough space for the coordinates. So the way that we're going to be looping through this is we're looping through rows. So these are rows. And I have not left myself enough space to draw this. These are the columns. So when we're going to loop through this, we're going to loop through the rows as the outer loop. So the first thing we're going to do is go to row 0. And then inside the loop, when we're at row 0, we will go to column 0 and we'll do a while loop through the columns going across here. So what we do is we go to row 0 and then we go to column 0, column 1, column 2, column 3. Then we go to row 1, column 0, column 1, column 2, column 3, row 2, etc. You know, so we are doing this thing where we're writing each row at a time. And then what we're doing is we're printing out the number that's stored in that row. So if we look at our array, it's this map that we haven't created one. So we're going to have to create one at some point to give one to this function. And the map we're assuming at this point, so this is actually slightly different. I've done a lot of other array functions where it was not specifying the size and it had some size information. This one's actually saying, okay, we're expecting this thing to be this size. And then what we're going to do is we're going to loop through these and say, whatever number that you've got stored in a particular coordinate there, we're going to print it out. But we've also got this condition here that says that if the I should probably do this in snake case here. But the question here is, we've been given inputs for where the tourist is. So the tourist will have a position R and a position C. So this is the position of the tourist in a row and column. And if we are where the tourist is, we're going to print out the T to show where the tourist is. Otherwise, we're going to print out the numbers that are shown in the map. So let's actually set up this world and get it going. So it's better if I call it a map rather than a world, because everyone's going to think I'm talking about a flat Earth. I'm going to change it. I'm going to do an int array called Earth and call it flat. No, I'm going to call it a map. And I'm going to make this a two-dimensional array. If it's a two-dimensional array, then here I said this has a certain number of rows and a certain number of columns. And so we're going to do the number of rows first, and then the number of columns second, because we know that in this we're using the rows as the first the first of the pairs of indexes that we're going to use, and that is going to make it, because of the way we print it out, it's going to make it these rows and the other one the columns, because we're always looping through the first of the two numbers first and then the second number afterwards, because it's going to be rows first then columns. Alright, I'm going to start this thing as zeros because I don't necessarily need any particular information in this thing to begin with. Also, if I want to initialize something like a 2D array, I'm probably going to need to write a whole function to do that, which is going to go through and either put zeros in everything. It's going to loop twice like this. So this setup here with this finish is most likely going to be the kind of thing that you'll be using anytime you want to look at every element in a two-dimensional array. So in the same way that we would loop in a one-dimensional array through everything, looping through a two-dimensional array is a loop within a loop. But anyway, here's my map setup, and I'm going to have a position for the tourist. So the tourist positions, I need to name these correctly. The tourist position is pretty simple because I'm probably just going to use an integer for the row that it's currently in and an integer for the column that it's currently in. If you've looked at the assignment yet, you may have seen the the laser in the assignment. The laser can nearly be represented just as an integer because it's just in one of the rows. Someone said he's behind you. Oh. What have I done? Oh yeah, no, someone else has already said pos R, pos C. So yeah, I think now that I fixed that there, hopefully that will be fine. Unless it's somewhere else in here. No, I think that's okay. Alright. So I've got my map there, and I'm going to have my tourist positions. So this is going to be two integers. So I'm going to use those two that I had before, pos R and pos C. And this is, someone said line 33. Have I done something weird? 36? 33? Did I add lines there so now I can't see where I'm talking about? Hopefully that's fine. Pos R, pos C. Yeah, I think that's fine, because these are the rows and the columns. There's the iterator things, and then there's the position things. We'll find out. If I've got any issues, everyone's saying line 34, there's an issue. Is there a typo somewhere? I actually can't see the problem at the moment. Oh, it's the equals. Thank you, everyone. I think this is important. I think important learning experiences to think that it doesn't matter how much experience you have as a programmer, how much time you've done in these gigantic projects you've worked on. The little issues are always there. The little mistakes are always there. So I think that the one thing that I want to say to everyone is don't beat yourself up if you make these little mistakes as well. They're going to be in your code here and there, right? None of us are perfect. It's more important what we do to fix our mistakes and how we recover from errors than it is to try to stop errors from happening. I mean, we do obviously want to try to stop errors from happening, but there's an understanding that they are inevitable, and it's a matter of just trying to fix those things instead. Also, it would have taken less time to compile this and get some information than it did me looking through and getting confused. So sometimes you can just pick it up in testing. But yeah, the thing I want to say is that don't worry too much when things are weird. So I'm using this particular way of creating multiple integers of the same type here. We can actually just put commas in between them. So because I haven't set these up with values, I can just do this. So if I want to give the tourist a position, so what I might do is try to put the tourist in the middle of the map. There's no exact middle of the map because it's 10 by 10, but I can do a roughly middle position of the map like this. So what's hopefully going to happen is there'll be a tourist somewhere in the middle of the map, and the map is the right size based on the hash defines that we have there. Good time now to have a look and make sure this stuff is working, and this is why we have the print map function, why we went to the trouble of making the print map function first, is we can always just say, hey, run this and see if our information is correct. So this is also why we do this in the first assignment. So we're giving you a hand with what we call visual debugging. So when everything that we're doing is in a space that's kind of like a picture, it's much easier to see whether whether the work for your assignment is actually working correctly or not, because you can always just print it out, and we wrote the print command to make sure that you can always see whether the stuff you're doing is actually ending up in the right place or not. So with this we can do the print map, and the print map is going to need the map itself, which is the two-dimensional grid of that size. So when we want the whole grid, if I wanted a single square of the grid, I would use the square brackets to get a single square. When the function wants the whole grid, we just give it the whole grid by name. If it wanted an array, I could give it an individual array like this, but that gets complicated. So we're going to give it the whole map, and it wants the row position of the tourist, and it wants the column position of the tourist. So this print map function here, I'm going to use this probably multiple times in this program. This print map function is going to show us what the current state of the, hang on, I'm just going to clear that. What the current state of our world and our tourist is. So let's compile this. It's taking longer than it should. Is everyone else running stuff on VX3 at the same time as I am? Okay, that compiled. I'm not sure why that was slow. I think maybe there's a lot of courses running at the same time that are running a lot of stuff on the same computers. Okay, let's run this, and what we should get is, here is our map, and we set up our map as all zeros. So this empty thing is going to make all of these zeros, and then the rough position of the tourist of rows divided by 2, columns divided by 2 is going to give us 0, 1, 2, 3, 4, 5. 5 is half of 10, so it's in the right row. 0, 1, 2, 3, 4, 5. So the tourist starting position is 5, 5, which is fine. That's close enough to the middle of the map. All of the 4 of these squares are pretty close to the middle of the map. So now we know that I've been able to set up my position correctly, and I'm printing out that correctly. Go back to my slides, see if there's, it's always like, remind myself if there's anything I need to talk about. So we've set up a grid and the tourist position. The tourist is going to move one step at a time, so we can think about movement now. And then we're going to think about when the tourist visits a location, we're going to set that to 1, or we're going to count how many times the tourist has been there, that kind of thing. And we can check locations afterwards. But let's go, this next step here is to move the tourist. So we've got our square grid. This is the same thing that we did there. Oh, I actually did it even more shorthand here. So let's do that. We might as well, because it actually makes this a little bit easier. I can do this initialization. Actually, it wasn't 0. It was in the middle. So you can do the, I actually don't want to do this anymore, because this now makes it look like I only made 1 integer. I don't like the style, so oops. This is much more clear that I've got 2 separate integers here. Okay, so we set this up, so let's think about movement now. So with movement, we have only things like integers and doubles that we can work with. But one of the nice things about doing that stuff with integers is I could use the number pad directions to move ourselves around. So if you look on your keyboards, I mean, this is awkward because my keyboard doesn't have a number pad, but if you look on your keyboards, you'll be able to see that on the right hand side, actually, heaps of people using laptops are not going to be able to see this, because most laptops don't even have these anymore. But we have a number pad, which is the grid of numbers. So 1, 2, 3 on the bottom, 4, 5, 6, 7, 8, 9 at the top, and that can actually form a grid of directions that we could use. So someone's saying WASD, the WASD. When I teach you how we're going to use letters as variable types and stuff, we could use that. But for the moment, we're going to use the numpad for the directions, and we're going to do some looping so that we can repeatedly take information from our user about the direction that we want to go next. So here is an input gathering if-else statement. So basically what it's going to do is it's going to keep doing scanf, and then this is inside a loop, by the way, and then every time it does scanf, it's either going to change our position somewhere, or it's going to exit. I'm going to talk through this as we create it, rather than like just showing it there like that. So what I might do is, I was wondering if I could put this in a function. I could potentially put this in a function. This gets to one of the fiddly things about functions that I will explain later, but it might still be worth doing. Oh no, I can't. I can't, because I'm trying to change two variables. I will be able to do this later when I teach you other things, but for now I can't, because the position R and the position C, either one of them might change, and if I can only give back one integer, then I can't do this yet. So I'm not going to put this one in a function. We're going to do this one in the main. Okay, going to get myself some space to work with here and think about what I'm going to do. So take input, check which direction to go. Depending on the direction, change the pos R or pos C. And all of this is going to be looping for multiple, I'm going to call it turns. So this is, you know, I've spoken about this before, so I think this should be getting through to everyone now, that one of the ways that makes it really easy to do your coding is to think about the process that you want your computer to go in, and say, okay, I'm going to write all this out first, and then all I need to do then is translate this into code. It makes it much easier. So I know take input's going to be scanf, looping's going to be a while loop, checking things is going to be if statements and stuff. So this makes it easy for me to get going. So I know I'm going to loop for multiple turns. So it's a while loop, and I know that each time that that's going to do something, it's going to take input. So I know at some point I'm going to exit this loop. So I might just add a guess, set up something like this, which is keep looping, and while we keep looping, we are going to run this while loop multiple times. And every time we run this while loop, we're going to take input. So I probably don't need this comment, but I'm going to delete it now that I know that I've done something. So I know I'm going to do some scanf. In order to do some scanf, I need a variable to put this in. So I'm going to call it input. I don't know whether I need to initialize this or not, but I think I am going to initialize this in case someone gives me incorrect input. Then my scanf is going to scanf in a number, and it's going to put that number into the input. But I do need the result of my scanf to be somewhere so that I can decide whether I'm going to keep looping or not. So I'm gonna try to name these things a little bit verbosely, which is like lots of words. Basically, that's what verbose is. It's like what I am as a human. I talk a lot, so that you can see exactly what I'm doing. So I'm keeping the input result of the scanf here. So if the input result is 1, then I know that we're fine. If the input result is anything other than 1, then I know that we did not scan in anything correct into the input. Oops. So if input result was not equal to 1, then we can't keep looping. Yeah, I can set that to 0. Otherwise, I'm not sure what it didn't like about what I just typed. It didn't want me to put an else statement in there. Otherwise, input was a number. So if the input was a number, then this happens. Check which direction to go. Copy paste that in there. I don't need this down here anymore, so I'll delete it. So we're going to have 4 different directions we can go in. Up, down, left, and right, or north, south, east, west, if you want to call them that. Cameron's asking, is there advantage to having a sentinel in the loop, as in the keep looping variable, versus having the condition here in the loop? So we could do this if we wanted to. We could put the scanf in the condition of the loop, which is kind of what we did in the scanf demo before. I'm going to leave it as it is for the moment because I've already kind of half committed to this, but I think that it could be interesting if you want to do what we call refactoring, where we rewrite the code, but the code actually does the same thing, but we rewrite it. So it would be interesting as like a half challenge for people, if you want to, is take this scanf, put it here in the while loop, and then see if you can rejig everything else in here to make this work after we're done with it. Yeah, because I think that it will end up doing the same thing, but it might actually make the code a bit more compact and easier to use. So we're going to turn off the loop if we didn't get a valid result. If we did get a valid result, then we're going to check things. So let me just look up numpads. Here's a nice one. I'll just look up images of numpads. So you can see all of these are numpads. Oh god. This is what I was hoping we wouldn't get, is inverted numpads. So on computers, numpads have the 9 in the top right corner. So don't use this one. We're going to use this one, right? So this image is a big one, so we can see it. So 7, 8, 9 at the top. And this even has the arrows on it. I'm pointing at my screen here. Or because it's zoomed in, so I can't. So this even has the arrows on it, so I know 8 is up, 4 is left, 6 is right, and 2 is down. So if input was 8, up. I'm gonna do my layout first of this, and then deal with what I'm going to deal with what we're going to do as a result of these tests afterwards. So else if input is one of the other numbers, so there was 8 and I think 6 was right. And you can see how these comments are definitely going to help us. Anyone plays a lot of computer games, this code for every single key on the keyboard is in pretty much every computer game that you play. Somewhere in it is all this code, which is just testing for individual keys, and then given those keys, take some kind of action. we actually don't even have to write this code a lot. So in game engines and stuff, this kind of stuff, checking for these individual key presses, is usually somewhere in what we would consider the standard libraries for those things. So left is 2. Oh, sorry, left is 4. And 2 is down. Let's go back to that image and make sure that's correct. So 8 is up, 4 is left, 6 is right, 2 is down. 8 is up, 6 is right, 4 is left, 2 is down. Okay, good. So I've probably got the right directions. Say probably, because I'm never sure. I might actually just do an else at the end of this. So it doesn't really matter whether the input started at 0 or not. But any other thing, invalid, or any other number, we might just say that if it's anything else other than that, we're going to stop. So if you give us anything that we can't use, we're not going to loop back again. So we're using a sentinel value to just exit on anything that wasn't a valid direction. So now we need to think about, if we have these directions, what effect are they going to have on our tourist? So these need to change the position of the rows and the position of columns of the tourist. So we go back to our diagram here, and we say, okay, this counts downwards, this one counts to the right. So if my tourist is here, and I move my tourist up 1, the column value for the tourist doesn't change, but the row value for the tourist, if I go up 1 step, the row value for the tourist goes down by 1. So 2 goes to 1. So I know I'd minus 1 from the row value to go up. So if this is up, I take my position row and I minus 1 from it, and that should move my tourist up 1. If I'm going to the right, we go back to my diagram. This is why I draw a lot of pictures when I'm coding. It makes it easier to think about what's happening. So if my tourist started here and it goes to the right, I know the row number doesn't change, but the column number goes up by 1. So position column plus plus. What I want to teach you about a bit is why I do a lot of live coding, is I want to show you ways that you can program that make it easier for you to think about what you're doing. So the first thing I did was just do this kind of mapping between the number and the direction. And then after I've done all of those, I go, okay, the only thing I need to think about is the direction and then the coordinates. So what I'm doing is I'm compartmentalizing which variables I'm thinking about at any particular time. So I'm not on a big kind of like thing about, okay, this whole thing I need to think about at one go. Instead, it was like these inputs I need to think about, and I put the comments in. Once the comments in, I only think about what I need to change based on this. So there's a lot of ways that you can code that just even instinctively in the bit by bit of creating things, you're breaking things down into smaller problems so you don't have to think about too much stuff at once. So that's one thing that's like one of the reasons why I do a lot of live coding in this course, is so you can see me separating this massive problem of moving the tourist around into all of these tiny little problems that are on their own actually really easy to solve. So I keep going back to this and showing you the movement. It starts to be like, okay, you don't need to show me that. That's really easy. And it's easy because we separated it. So left is going to be the opposite of right. So we don't even need to look that closely. We know that the column's going to go in the opposite direction from the left and the right. And down's going to be the opposite of up. So in the end, something like this, which is actually like, 20 lines of stuff, and it's a bit fiddly and stuff, is actually pretty simple when it comes down to it. Okay, so the else there is probably not going to matter if it changes the position row or column, so we don't do anything there. So what we should have now is a loop that will keep taking inputs from scanf, and every time it runs, it will change the position of the tourist if it has been given a correct direction. Because this is a game where we're expecting some kind of feedback, we're probably going to want to print the map each time. So I wonder if we're going to print this at the start or the end of the movement. I think we'll print it once at the beginning, and I'm going to copy this and say each time we move, we're going to, after we've done our movement, we're going to print the map out. I guess that makes sense. Yeah. So let's save this and run this, and we'll see this loop running multiple times. I will put in input multiple times, and we'll see if the print map changes every time we move. Just going to clear the gedit warnings there. Compile this, hopefully. Well, no one's been yelling at me about about any typos that I've made, so I was hoping that this was going to compile. Oh, someone asked, is it possible to clear the terminal in C? Yes. We can do clear, or we can do reset. Reset actually restarts the terminal. But yeah, we can do that. And I'm going to go, did I compile? I think I did compile. And I could have typed that in. I press up arrow so many times. Up and down arrow goes through your previous commands. So, run the tourist. So, we have the tourist here, and let me say I want to go up. The tourist is now 4 from the top instead of 5 from the top. Let's go to the right. I can go to the right, I can go to the left, I can go down, and it's actually starting to look like it's animating now because this is printing in the same position every time. 4, 2, yeah. So it's actually moving around now based on the input, and so I could give it some rubbish input like this. Actually, it's probably going to take that 4. Let me just type in a number that wasn't one of the ones it can use, and it's like, okay, that's your final position, and we are done now. So I could, if I wanted to, and I think I did in the lecture slides, I could have a specific number for exiting, but this time I just decided, yeah, you don't have to just any number other than a valid input, it's just going to exit. Someone's asking, can you make the terminal so it doesn't need to press enter? Yes, you can. It's much more complicated than this, but there are ways of doing it so that you can just take the input immediately. Well, it's kind of out of the scope of what we're doing in 1511 though, but there are ways of doing it. You can actually probably look it up. There's people making retro games and stuff like Dwarf Fortress and Rogue and all those kinds of like old school, like in the terminal character games that can actually do that. So if you're interested in that kind of stuff, yeah, you can totally look that up. Okay, so now we've got movement, which is cool. Where are my slides? Oh, wait. Here. Hopefully I don't need that again. Okay, so this is now movement. Oh, I could have actually done this instead rather than ending the loop. I could have said, hey, that wasn't correct. Go try again or something. But for the moment, I think we're okay with what I've created there. So the next thing we want to do is track where the tourist has been. So everywhere we've been, we're going to set the position on the map to 1. So what we're doing now is we're accessing one single square of that map and setting it to 1. That way, what we'll be able to do is track where we've been. So I might actually do this at the beginning of this loop to say track where we've been. So we say whatever position that we're in when we start looping to get input, we're going to say that that position on the map is marked as a previous location. So our current location is the position R, position C. So the row position that we're in, the column position that we're in, this gets us to an individual number, which I can set as 1. So this says I've been here before, and then we can start going through and doing stuff. I might actually be polite to my user here. So I'm just going to put a printf in there to make it a little bit more polite, to be like, rather than me just typing in numbers there, it's actually going to give us a prompt to move in that direction. So we do that, we do our movement, and now with this setting up where we've been on the map, we should actually be leaving a trail behind us of positions we've been to. So I'm going to save this and compile it and run it, and we'll see if now my movement is leaving behind me a trail of places that I've been before. Anyone ever played the snake game? Anyone got or has seen an old Nokia telephone? They had this game, which was this, and you just walk around as a snake. But it was real time, so it was much harder to do. And then you had to actually just try to not run into your own tail, which is actually what we're doing here. Well, I could have called this the snake game rather than the tourist game. What do we... Ooh, lots of interesting things. Oh, people are talking about if the character goes off the screen. Let's go off the screen and see what happens. So, to the right, to the right. Oh, I broke everything. What happened? Runtime error. Index 10 out of bounds for type integer array 10. You were using an illegal array index. 0 to 9 would have been fine, 10 was incorrect. So that was a great thing that someone said that in chat, because that's super interesting. What happened there is actually, I love it, because this is where I was going to go. It's in the slides. You know I was actually planning on going here. This was getting us some useful stuff where, well, not that one, this one. Tracking where we've been. But if we move off this grid, our position row and our position coordinates, our coordinates can actually get off the map. So once we've gone off the map, there's no way for us to mark on the map where we've been. I can't put a 1 there because I've gone off the edge of the array there. So I've tried to mark a 1 in this array position here, but that array position doesn't exist because this is a 10 by 10 array. So I've started trying to write information outside of my array, and my program said, no, you can't do that. You can't just go off your data structure, your two-dimensional array, and start writing information elsewhere. Someone said the tourist left the resort and got murdered by the local wildlife. An interesting thing about this is historically something that someone did was they made a snake game that did exactly what we're doing now. It just walked around inside an array setting 0s to 1s. And this was a really, really old school compilers and operating systems that didn't care if you went off this grid. Like, they were like, oh, you're just writing to memory. And so this program went into memory and it just went through the RAM of the computer, setting 0s to 1s. And it was just like, he actually just let it run and it let it keep going. And it got some of the funniest crashes. I think the funniest thing that it did was it opened the CD drive on the computer. And we don't really have CD drives anymore nowadays, but we used to actually put CDs in our computers, and this thing managed to find itself all the way through the operating system without crashing it, into the point where there was a bit that you could turn on or off for whether the physical drive would open or not, and it actually opened the drive. So it was this funny thing where most of the time just crashed the computer immediately because it found its way into the operating system and started rewriting what the operating system was trying to use at the time. So we have a problem here, and luckily we're using DCC, which is much safer than other compilers. So us going out of bounds like that immediately says, okay, we can't do this. This is a problem. We're going to fix that in a second. But before we go into the walking out of the map, I want to actually at least complete the game as it's supposed to be, which is if we move somewhere where we've already been. So if we see this 1 where we've already been, we want to say, oh, this is bad. The tourist is like, this is very boring. I've been here before. This game is over. But before I do that, I want to make this easier for us to understand. So I'm going to do 2 hash defines here. Oops. So the cool thing, I don't even know if I'm going to use this other one, but it's nice to have it in case I'm going to use it. instead of having magic numbers like these 1s and 0s in my code, if I have words like this in my code, it's actually a lot easier for me to understand why part of my code is doing what it's doing. Because if you look at this, as opposed to the one I put the word explored in there, this line of code suddenly becomes much more readable to me. I am saying I've got a position somewhere in the map, I'm setting that position to explored. Makes it very, very easy for us to work with now. So what I'm going to do is I'm going to move, I'm going to print the map out, and then I guess this is a good place to do this. I think after I print the map out, I'm going to do a check. So I'm going to say if my current location, check to see if current location was already explored. So if my current location, which is the map of my row and my column, has already been explored. Oh wait, no, that's not good. That's not good. I've already set that. Oh no, I haven't. Okay, we've got to think about the timing. When we start the loop, we look at the position we're in, we set it to explored, and then in the loop we move somewhere else. So wherever I'm moving now, I have not set it to explored yet, because this is the end of the loop, not the start of the next loop. So I've already moved out of that position, or I have done something bad and I've ended up in the same place. So if I didn't move at all, so I gave incorrect input and didn't move at all, I'm going to trigger this condition because I'll already have explored the square that I'm in. But if I move to a new square, I can now check if it's explored here. And if it had been explored, I will say I've already been here. How boring. And the worst thing that we can do is make the tourist's life boring. And this will end the game here, and we're going to end the game here by flipping our sentinel loop, saying you don't get to loop around anymore, that's it. How boring. We've already been here. So this will end the loop here. Well, not end the loop here, it'll go back to the start of the loop, and then it won't run again. So it's not ending in this specific position. We're keeping the flow of the program. We know what's happening. Okay. So hopefully now we're in a situation, we still haven't worked out the walking out of bounds, but we have a situation where if I visit somewhere where I've already been, my tourist should spit the dummy at this point and then stop exploring. So let's try running this. So what we did before was we're tracking where we've been, and now we're going to see if we revisit somewhere, the tourist is not going to be happy with this. Okay, let's compile this. We are still in this small civilized area where everything outside of it is carnivorous jungle. So if we do walk off the edge of this thing, the whole thing is going to crash. But we'll fix that in a second if we get time, which we might. So I'm walking upwards, I'm walking to the left, I'm walking down, and then I'm walking to the right. And we go, oh! We went back over our path where we'd been before, and the tourist says, I've already been here. How boring. So what we're able to do now is we're able to set positions on the map as we walk past them. Oh, sorry. This is the set positions on the map. Every turn, we start in a location, and we say, okay, we've now been in this location. And then after we move, we check the new location we've just gone into, and we go, have we already been here or not? So we're looking at the ability to write data into this two-dimensional grid and also check if something has already got that data in the grid. So we're getting a lot of kind of ability to work with the positions in this grid and change their values. So if, for example, I wanted to put stones in a square grid for something called slide, I could use code like this to set certain positions in this to certain hash defines that I have. If, for perchance, I don't know, maybe I wanted to do that to get marks in an assignment. Anyway. So strangely enough, what I'm teaching you is useful for what I'm assessing you on. So if you're listening and you're understanding this, then you will be able to get started on the assignment. If you don't understand it yet, there's plenty more of this kind of stuff that's going to be in next week's tutorials and labs, which should help you as well. Okay, so we've got this. This is our game reasonably working. Like we're tracking where we've been. And we have our lose condition, which is like if we go where we've been before, we stop. But we've still got that potential issue where if I walk off the edge of the map, I have caused a great deal of issues, and I don't want my game to end with this. So I'm okay with the game ending on me making a mistake and something, and it ends correctly where it says, okay, you have... Where was it? You have failed. The game ends. But I don't want my game to end in this kind of crash. And I think if anyone here plays a lot of games, you'll know that anytime a game crashes like this, it's a really sad moment. It's like, oh, when was my last save point? Or something. Or I was in the middle of something, and like, if the game was going to fail for any reason, I would have preferred to actually know about it. So, instead of having it just crash like that, let us look at the possibility of checking if we've gone off the map, and if we have... Sorry. Not supposed to react too much to comments in chat, but it was like Cyberpunk 2077. I did manage to finish that game eventually after all the crashes, but then I just promptly deleted it. I was like, I'm done with you. Okay, so... Oh, that's a cool one. Someone said moving off the edge should print out so long and thanks for all the fish. Or fell off the world or something. We could do that, but I want to do this a little bit programmatically, where what I'm going to do is I'm going to say, if someone tries to go off the map, I'm going to put a fence around the map. So if you walk into the fence, you just don't go anywhere. So there's several different ways we can go off the map. And if we look at our map here, there's 4 different directions we can leave via. So either the rows goes below 0, that's me going off the top. The columns goes above the 3, that's off this side. The rows goes above 3, that's off the bottom. Columns goes below 0, we go off the left. So there's 4 different situations where we can leave the map. So let's do some if statements for these. So if I said off the top of the map, if my position row is less than 0, this is the top of the map. Else if, let's do the same coordinate, if this is greater or equal to the size of the map, which is the number of rows, we've got a define for that, so that should make that easy. That's the bottom. And then we've got left and right. The position columns is less than 0 is the left. I'm just doing this off memory of here. So less than 0 is the left, yes. And greater than the size, greater than or equal to the size, because this is size 4, is off the right. Greater than equal to the number of columns. Just checking my time there. I think we've got enough time to do this. This is okay. So, if we've gone off the map in either of these, in any of these directions, we want to correct where we're going. So, I've actually shown you a technique we can use to make sure something stays within the boundaries of something, but doesn't actually get pushed to a random location. It'll just stay in the kind of location it was in. Someone's just like, wait, this is just Bootleg Snake. It is just Bootleg Snake. It is exactly Bootleg Snake. Okay, so if we go off the top, it means that our position R is incorrect. So if I've tried to go beyond 0, off the top of this map here, if I want to put a fence here? So if I want to put a fence across this, what I can say is if you try to cross this fence, you just don't go anywhere. You're going to end up in the same space you're in. So I need to say that if you tried to make 0 into -1, you're going to end up at the same space you're at, which is at 0. So let's do that. So off the top, position R tried to go to -1, so it tried to go less than 0. You're just going to go back to 0. So if you tried walking off the top here, you just get placed exactly where you were. And so this is good because I don't want you to get teleported somewhere. I could do the thing where you wrap around to the bottom, but it doesn't kind of make sense for the examples. Like, how's the tourist teleporting, right? And so off this side, you end up there. Off this side, you end up there. And off the bottom, you end up where you were. Some people may remember this because all I'm doing here is doing the same clamping thing that I did for the dice as one of the possible ways to correct the dice. So if position R tries to get to or greater than the size, it must become equal to the size -1, which is the final index that I can use in an array, is the size -1 index. So this puts it back inside the array. And again with the 0, if I tried to get below 0, leaving the array, I'm going to be at 0. And then if I tried to go to the size or higher off the index of the columns, then I do -1 off the size. So then I am, as you can see, this is size 4, and 3 is 4 minus 1. That puts us back inside the grid. The interesting thing that's going to happen here is you're instantly going to lose the game if you try to do this, right? Because if you try to go off the grid, you're going to end up exactly where you were beforehand, which means it's going to say, I've already been here. So it's kind of like, as we said, someone's even making bootleg Snake. It kind of makes sense because if you hit the walls in that game, you also lose the game. So we're in a similar kind of thing. I may end up renaming this example to Snake, actually, because it really is Snake at the moment. Okay. So this clamping thing is now going to, I should actually say that we're clamping here. Clamp to legal map positions. Now if we run this, hopefully we're not going to get any crashes like this. And instead, if I try to walk off the edge, I am going to lose the game, but at least I'm not going to get a crash from it. So, oops. I typed in 5 by accident, so I didn't move anywhere and it ended the game. Let's try that again. Okay, so 6. We can go up. We can go left. Let's go off the edge of the left. Oh, see, my tourist did not move, stayed in the same position because I tried to move off the left edge of the map, and it says, we've already been here. How boring. Okay, I've hit 1 p.m. So the lecture is finished there, but that's all the code that I wanted to show today. So I've done explored. Okay. So, and we've done this. We've tried this and we've moved around a bit and we've seen that we go off the map, and so we've done the clamping thing there. Okay. So that's where we're at. We've been able to, in this lecture, we've been able to navigate a two-dimensional grid. We've been able to change the values in a two-dimensional grid. We've also been able to check for values in this two-dimensional grid. So here's a mini challenge if people are interested in doing this. There's also a maxi challenge, which is worth real marks, which is this thing called slide, which is the first assignment, which uses the same kind of two-dimensional grid. But if you want a little challenge, I have an idea about scoring, is could we give the player a score based on how many places they visited before they eventually either tried to walk off the map or went where they were before? Like, are there ways of calculating the number of places they've been? There's 2 ways I can think of doing this, but I'm not going to say because it's a challenge. And so how would you want to calculate how many of the spaces in the grid were explored? And the other thing, which I've been dropping hints about the whole lecture today, is yes, some of this code might be very, very useful in the first assignment. Okay, so I'm going to wrap it up there. That'll be the end of the official lecture here, but I'll come back afterwards for questions. Also, reminder from Michael, it is in the lecture section on the website. There will be a live stream on Thursday, which is just talking about the assignment. It's optional. It's not necessary. If you think you have a full understanding of the assignment and you don't need to hear any more about it, then don't worry, you don't need to go to that one. But if you want to, you can always come along. I've set it at a time where there's a minimal number of clashes, because I can see everyone's timetables, and this has a minimal number of clashes, but there are some clashes. So either way, it's going to be recorded if people want to watch it later. Friday's lecture, we're going to continue delving into C, and we're going to be looking at actual memory and how we use memory itself. I haven't put that up on the website yet because I haven't prepped it, but it'll go up soon. Alrighty, thank you all. I will go into my Be Right Back screen, and I'll come back in a second and answer any questions, go back over code, explain things and stuff like that if people are interested. Alrighty, we're back. Lots of questions there about the assignment. Yes, we're gonna. I was keeping the assignment stuff out of the lecture. I mean, like, I wrote a whole lot of code that's useful for the assignment, but that's code that's useful to know in general. But in terms of really specific stuff about the assignment, I'm saving that for Thursday. I want to keep the information kind of separate so that if people want assignment specifics, they can go to one place to look at it. They want like all the theory they need to know, they can come here and kind of watch that stuff. So I'm trying to just keep those two separate a little bit. Not that I'm not going to answer your questions, and I think the questions are being answered in chat anyway, but trying to at least make it easier after the fact for people to look for information. And also, if you're doing your study for the course, for the exam at the end, you know that you can skip the assignment streams then. Cactus TNT, that's your real name, isn't it? was asking how long the assignment live stream will be. It'll probably be 2 hours, I would say. So it'll be like the Friday 4 to 6 p.m. thing. Lorenzo's asking, have we officially learnt about what Control D does or not? I mean, sort of, in that I showed it a bit today, but it hasn't been in any other content. So basically, Control D is your way of saying to the computer that you are not giving any more input. So this is the end of the input. So scanf can actually look for that in a sense. Well, it's not really looking for that, but it's looking for a lack of valid input. So Control D is like saying this is a thing that doesn't match anything in scanf. So no matter what symbols you put in scanf, Control D is always going to make scanf say, I did not read that, in a sense. So it's like our way of, in the terminal, saying we're finished with giving you input, and we don't want to just like spam the keyboard with invalid input to make it end. We want to be really specific and say, okay, no more input now. So that's what we're using the Control D for. Brendan saying, would it be possible to code an extra row and column for the snake game and make it so the tourist reaches the last row and column, it refuses to let them move there or teleport them back? You could if you want to. Okay, there's lots of little things that you can do with this. So if you wanted to, you could have the number of rows and columns, and if you wanted to, you could put a buffer around it. So when we print the map, we could do something interesting. I mean, I don't want to edit this code too much, but we could start from a -1 and go until equals the row columns. And then, obviously, we can't do this because we'd be trying to access invalid array bounds. But we could put a border around this thing that has some different information. So we could do that in the printing. I'm going to set this back because I don't want that to be I don't want that to be the code that people use afterwards. Oh wait, what is this? I think that's in here. No, not in here, in this one. That was me writing my comments to remind myself what I was doing, which is obviously no longer necessary because it's already been completed. Yeah, so we could have a buffer around the edge, or we could even make it so that this is the rows and columns, and we do this. So there's a buffer on either side, and then we can say, all right, in order to do that, we're going to need some offset for the positions to make it work and stuff like that. But then we can say, if you ever cross over into those buffer regions on either side, as in, if you hit, and so this check here, instead of it being less than 0, it would be less than equal to 0, and this would be greater than or equal to n rows -1. We would have this larger grid where we'd have this buffer of squares on the outside edges of the grid, and we can do something with that. Right, so there's a lot of little manipulation you can do where this is the official size, but you can go, all right, there's a buffer on the outside, and then we can say when we print out that buffer, if we're outside of these, not these, if we're outside of this, outside the map, we can print something different. So we can have like just X's around the outside, and so that would kind of, it's nearly like us putting a border on the map. We could totally do that. So play around with it, because you can take what I've got here and then just run with it, you know. Like there's a lot more possibilities, because this is only 1 hour of coding from me. You could spend weeks on something just like this and make a simulation of a side-scrolling arcade shoot 'em up, maybe. I don't know. So I always laugh when I'm doing it, because this exact example that I did here was actually one of the candidate ideas for the first assignment. It's not complicated enough, and there wasn't enough other stuff to do, but you could see how I could do this as the first assignment and say you've got to walk around, and then if you hit certain squares, it changes something else, in the same way that if you've looked at the assignment, if we shoot certain things with the laser, it changes more in the grid than just the cell that it's in, and stuff like that. So you could see how I could definitely take this tourist or snake game, as you'd call it, and turn this into an assignment of the same difficulty level as Slide, if you've looked at Slide that much so far. So Lorenzo's asking, where else can we use Control D? So Control D is going to basically, like, if you want to look at the details, Control D is going to send a signal to the program. If the program is accepting input, it's going to send a signal to the program called EOF. EOF is actually a hash define. I think it's definitely in standard input output. It might be also defined in the standard library. I know there's several of the the important hash defines are in multiple of the C standard libraries. It's funny, if you look at the C standard libraries, they have a whole chain of other things that they include, which is the back end of C, and so a lot of them will include the same things. So that symbol EOF, it actually looks like this. You can, I think, if you want to, I think you can even do stuff like this. You can set it to an integer. I can't remember if it is actually a specific value or it's different values depending on your operating system and things like that. But often, I think EOF is often -1. But I have no guarantees on that. I tend to use it as a symbol and not think about what number it is. But yeah, that's the symbol that will get sent through to your scanf. Then your scanf will say, if I receive that, then I definitely did not succeed in getting any input. When we use other types of input, because scanf's not the only input we're going to use, there's actually other things we need to use for different purposes. When we start using those, we'll actually start using EOF a little bit more. So yeah, Control D is just basically saying there will be no more input. And it's a signal that goes through and says that. Yeah, so Brendan was following on that. I was like, yeah, extra rows and columns that aren't visible. So yeah, definitely, because if we wanted to, right, when we're printing this out, we choose exactly what's going to be printed out. So we said start at 0 and go to that. So this was definitely printing out everything that's in this array. But, you know, as you can see, we can construct the array in different ways. Or we can say, we're not even going to show you all of the rows. So I can start from row 5 and column 5 and go, look at that. You can only see the bottom right quarter of this map, and hopefully you can still navigate without that. I mean, obviously, that doesn't make sense for the game that we made, but like other games might do that. So another game might have this concept of the fog of war, where you can only see bits where you've been before, and other parts of the map are actually grayed out, or they're covered up with a different symbol or something like that. You could do some cool stuff like that. You could turn this into a 2-player game where each player sees a different thing. You'd have to both have access to the same bit of memory, which is, okay, we're getting way beyond 1511, but yeah, you could do that kind of thing as well. So Lorenzo was asking, is there a way to have an expression that some variable is equal to or not equal to a set of numbers, saying x not equal to 2, 4, 6, or 8? There isn't necessarily an expression for that, but there's definitely a function for that. So I could do something like check input, and I could have this function, and I'd write this function here, which says actually, there is an expression that would do this easier than what I'm doing, but anyway, because I'm about to do it now. If input is equal to 2, or input is equal to 4, or input is equal to 6, or input is equal to 8. That's the expression, actually. There. It's a bit chunky, though. Result is equal to 1. So this is saying if it's any of these 4 are true, then the result is equal to 1. Then we return the result. This is actually a really nice kind of thing, because we can take all of this and go, all you need to do is run this function, and you don't have to do all of this. Especially if we start to add heaps of extra possible inputs, like say there's like 20 keys that do something, then this, just using the phrase check input, is much nicer than putting this massive OR statement in here. Yeah, inside here, to check if it was the correct input or not. So yeah, we could do something like this if we wanted to. I'll leave this out because I think this might be just a bit confusing to have this there. But yeah, you could totally do something like that. These are the things that you can see, like my instinct was, if you want to check input, I want to push this out into a function because I know it's going to be code that just kind of messes things up. It just adds more information, more noise inside what is already quite a noisy while loop. So a lot of this stuff I would try to change somewhere. So the downside is this bit here. I really want to push this into a function, but it wants to change multiple possible variables, and the function can only give you back one result. So I am going to teach you later how you can change multiple variables in a function, but for now we couldn't do that, so I nearly wanted to push that out. This one you totally could. Oh no, same thing. It's changing multiple variables. Yeah, so it's hard. I guess we could do a clamping function that has the 0, the n rows, and the position, and it'll clamp either one of them, and you'd run one for each of these coordinates. But again, then we're nearly doing as much work as just writing it here. So there's always difficulties for deciding what goes into a function or not. Because I think what we ended up with here, we couldn't really put much of this into a function. The print map, obviously, which takes a lot of this out of it, which is nice. Okay. Zach is saying, why do we only learn while loops and not for loops? The reason for that is basically that they both do the same thing. So when we're trying to teach people about programming, we just pick one that's going to work. And while loops work much better than for loops when you're just learning about programming and haven't used any of them before, because what they do is you have to do the setup in a variable declaration. So if you want a variable, you have to declare it the same way you declare other variables. The for loop does it in a weird way, right? Because it's inside the brackets there. If anyone's wondering about this, there's another type of loop called a for loop, which might go like this. So this for loop does the same thing as this while loop. The only difference is it does everything inside this expression here. So this is the thing it's testing. This is the thing it's doing at the very last line, which this one doesn't actually do at the very last line, so we wouldn't be able to do this thing in a for loop. And this is the variable that it creates for its use. So a lot of people like to use these because you have to do everything in the brackets, so you're less likely to leave this bit out by accident. But it can't actually do what we're doing here in this one because we did a printf after this incrementing of the variable. And this is the test to see whether it runs again. The only annoying thing about this is like you've just got to remember how to do all these bits and pieces, whereas this, you set up a variable the same way you set up a variable. The while loop layout is exactly the same as an if statement, so if you learn the if statement, you can learn the while loop really easily. This incrementation always happens basically at the closing bracket, so you can't do any things like something after the iteration. Although this could have gone before or after the iteration, it would have made a difference. I'm not sure why I did it afterwards. But anyway, yeah. So for loops are a tiny bit less flexible than a while loop, and also in terms of learning C syntax, you just have to learn like a new sentence structure here, whereas while loops are exactly in the same programming structure that we're teaching with all the if statements and everything else like that. It's the same reason why we're not using switch statements in this course, because they're a completely different syntax to all the other C, and there's no point, right? There's no point learning multiple different syntaxes to just do the same thing. So this is why while loops instead of for loops, for those of you who know for loops. If you don't know for loops, you can safely ignore them for now. And you'll get into these later, because after you're good with while loops, for loops are easy to use. But if you're trying to learn things from scratch, it's better to learn while loops than for loops, because their layout, syntax, and formatting is exactly the same as any other bits of code, whereas for loops is like, okay, this is special and different, and then you end up having to learn something else. So it's like, if I want to reduce the number of things I have to teach, I use the while loops instead of the for loops. That's I don't know if you expected that question to like go into like that much detail, but that's how it all works. So it's very much like, it's interesting because like, you know, if you've done other programming, you may know for loops, and then you're like, oh, okay, so there's all of this kind of stuff that that I guess you could know if you learn programming in a different way, but there's all these things where it's like behind these subtle things that make the initial learning curve easier, and so that's why the course is engineered in this way. So there's a whole lot of specific stuff that if I was teaching a course to teach you how to program in C, then I would teach C, but this is a course that's teaching you how to program that happens to use C. So that's why I'm cutting off parts of C that are going to be unnecessarily confusing, so that you can just learn about programming instead. So hopefully that answers. It's a longer answer than maybe you needed, but yeah, that's this question's obviously gone through my head a lot, right? It was like, oh, there's all these other things I could have taught, you know, there's all these other things I could add in, but I need to get this as like, you know, one of the goals of 1511. You can see that one of the goals of 1511 is to push challenge and get people doing interesting things, but that's not actually the main. One of the bigger goals of 1511 is accessibility. If this is the first programming course that people do, it has to be something that people with no programming capability can come in and by the end of it be programmers. So a lot of these things are like, if I show you 8 different roads that can reach a destination, then you could pick one at random and it could be really hard. But if I only show you one road and it's the same kind of road that you've gone on for these other things, then it's going to be easier to get there. And then afterwards you can look at the other roads and go, oh, okay, now I understand them because I took this one, which was the cleanest path to get somewhere. Anyway, yeah, so Lorenzo's got that really funny thing there. It's very, very subtle. Learning how to program in C versus learning how to program, in C. Yeah. So I mean, this is the kind of thing where I'm trying to teach you things that will last longer than C, because I know C has been around longer than most of our lifetimes, even mine. I'm not that old, but you know, I am still not as old as C. Heaps of the other lecturers are actually older than C, and for them this is like second nature. All programming languages are ephemeral. Every single programming language we're using at some point is going to be removed from the set of programming languages that are used generally, and so we need to always be able to jump between programming languages. So that's why the focus on the language can never be as strong as the focus on being able to code in general. Nyanda is asking, I don't know if I pronounced that right, sorry. When is my birthday? It's later in the year. It's in the second half of the year, so you probably won't be in courses with me when my birthday is. I'm not going to say my birthday because, like, I know enough about cybersecurity to not give any details that could be security questions for me out. Okay. So, any other questions? Oh, important question back there. Ryan was asking, where do I get assignment help? Good places to get assignment help. Talk to your tutor. So you can talk to your tutor in your labs. If you're online, you can go into a breakout room and it's safe to kind of show your tutor your code like that. Help sessions have now ramped up for assignment help. So that was in the notice that I sent on Monday. The first notice, because there were 2. There was one that had all the information for the week, and the other one was like, bang, assignment is here. The first one has a link to help sessions. You can get one-on-one help with 1511 tutors there. So you can bring your assignment in there and go, look, I'm doing this thing and it's not working. Can you look at it? If you want to ask on the forums, you can ask about generic topics. So you can ask about looping through part of a 2D array or something like that. But once you start asking, ooh, in that case, how about I do this specifically within the assignment context, then that will probably get deleted off the forums to make sure that we don't have a partial assignment solution on the forums or something like that, you know? So forums, good for open questions, theoretical questions and stuff like that. In your labs and help sessions, one-on-ones with your tutors to talk about things. a lot of the time your tutor is going to initiate one-on-one conversations with you. So every time we're doing the reflection marking, that's actually an opportunity for you to talk to your tutor. Most of the times when your tutor's having that conversation, they may ask you if you have any questions or anything like that. You may be able to then at that point go, there's a particular technique in the assignment that I'm not sure of, and your tutor will go, oh, that's interesting, right, we can actually go through that. And either they'll go through that with you then and there, or they'll say, let's set a time because you're not the only one that needs this help, and I'll go through it with a group of people, like little things like that. So your tutor's often first port of call because they're the person that's going to know who you are. And I apologize because I know some names go past here, but there's over 900 of you, so the chances of me meeting individuals is actually very low. So they know you and where you're up to and what you've had trouble with before in labs and stuff. This is what the reflection's about, really. So it's about getting the tutors to know who each and every one of you are. And so they've read some stuff that you've written and things, and they're able to say, okay, this is where I think this person's up to, and then I can give them the appropriate amount of help for these things. So hopefully like that. Sorry, I just get to the point where people are asking things. Autumnal Blake asking, there's no point using Switch and then Word Edition. Word Edition is a specific exercise to kind of teach you the context for which we're going to use arrays and looping and stuff. So it was made to show you like how what we taught you up until that point was not sufficient for the majority of the programming things that you might want to do. That's why it's a challenge exercise and not a core exercise, because just having to copy paste or retype out that much code is not something that we consider to be core for the course. But if people are looking at this is why a lot of the challenges exist. People looking at the ramifications of coding the way we are at the moment, or the code that we have existing in a certain context. We can see why other features are added to see later. So anyone who did Word Edition was really frustrated by it. Go back and do it now with loops and arrays. Should be really easy. There should be a way of doing it that is significantly easier than what was done before. But I leave that with you as a challenge. Actually, I should put that in as an actual exercise or a challenge exercise in, say, this week or next week's labs. I haven't. Apologize. But it's a cool idea to go, alright, if anyone did this Word Edition before, do it now. It's like people were like trying to get this thing under 100 lines of code and stuff like that. I think now it would be like 15 lines of code approximately to do it. Oh, actually, not yet. You need more. I need to teach you more before. We need to be able to use letters and stuff. So when we get to characters and strings, then Word Edition will actually be really easy. But not yet. Soon, though. Okay. Question there. Alan was asking, is print map a function? Yes. This is a function here. So this is the code that runs when the function runs. This here is what we would call the function definition or function prototype. Unfortunately, there's lots and lots of different words people use for the same things because programming is something that just sort of evolved and it's not super clearly defined. And this is the thing that tells your main that the function exists, and it takes an array, a 2D array, and 2 integers as input. And that way now we can use the function here, give it a 2D array and 2 integers as input, and it'll run. I think we use it again here. I'll put an enter there because they're different things. Yeah. So this is us sort of actively using functions now. So we set up the knowledge of the function so that the main can use it. Then in the main, every time we use it, we just call its name. And then every time my computer as it's running sees this name like this, it'll jump to this part of the code, set up these inside this curly brackets and start to use them. It's actually one interesting thing, I might talk about it later, is that this here, you can actually edit this map through that, and there's some really subtle things about why that's working and stuff, but I'll talk about that later when we know about memory. Okay, so Oh, Lorenzo saying it's amazing that C is still being used after it's 40 years old. Well, I mean, it's kind of interesting because C is 40 years old, but parts of C are much younger than that. And so heaps of stuff like the C standard library is like in active development in a sense. It's still being updated. C's as old as your mother. Okay. Ooh. Evan says there might be an error in the TNT example for the assignment. Oops, something just fell off my shelf. If you find an error, please send us information about that error, because there's actually a nearly impossible to get achievement, which is like, I think it's an achievement. I'll check with Tom, but I think there might actually be an achievement where if you find an error in the assignment, you can get an achievement, and that's one of those achievements that not everyone will be able to get, because once we've cleared up any errors that we have in the assignment, then that one will be unachievable, I think. So if you do, send us that. I don't know whether that's actually an achievement or not. We may actually be making it so that everyone has the technical possibility of 100%ing the achievements, because some people are trying to do that. But I remember seeing someone post on the forums that there was an error somewhere, and I knew that happened really late last night, so I only read it this morning. But that's going to get fixed at some point. I think, if I remember correctly, I don't know if it's the same error, the reference solution for the assignment is correct, but the way that we've written it in the spec needs to be updated. So we'll probably do that. So you hit the day 0 patch. It's not even day 0, so it's a few days in. This is like the version 1.1. It's like there's the version 1.1, and then we're releasing the DLC, which is the extension content. That's probably going to come out. I think it'll come out before the live stream, so that we can talk about it in the live stream. Autumnal Blake's asking about getting help from people outside UNSW. If you do get help from people outside UNSW, if you've got like a tutor or something like that, just be careful, because like if you talk to someone who is an experienced programmer, they could solve the entire assignment for you, and then that ends up being a plagiarism issue. And also, you don't learn anything if someone else does it for you, right? So if you are going to use anything from outside UNSW, make sure you credit it. So, I mean, like, people have done that before. I've had people in assignments say, I did this cool extra thing that wasn't actually the way it was intended, but I did this on top of the way that it was intended, and I got this idea from this thing off Stack Overflow and stuff. So it's just in their comments in the assignment going, here's the link to the place where I got this from. These are the bits that I used, but these are the bits that I modified and stuff. If you just explain it, things will be okay. I mean, if it's like, here, I downloaded the entire assignment from this other person and I've credited it, then we might go, okay, so because this isn't necessarily all your work, we have to modify your marks a bit to reflect it, but we're not going to like throw you to the wolves because you've credited things correctly. So if you credit it correctly, then it's not plagiarism. But then we'll still decide how much marks you're going to get based on how much help you got. I mean, heaps of stuff that you're going to look at, which is just like, how do I work with a 2D array? You know, there's heaps of stuff online about that. So you will definitely be, you know, Googling things and stuff like that. That is how we program. But if you're going to use code or techniques that other people have publicized, then you do need to give them credit for it. So those are like the kind of the subtle details about how much you use from outside versus how much you write yourself. Oh, Zach is asking about, it's not on the style page, but are there any style tips for indentation of comments? My tip for indentation of comments is they should be indented the same as the code that they're in. So if this is inside of curly brackets, then it's indented. We shouldn't necessarily be non-indenting comments like this. The only time I would not indent comments is if I was doing something that I really wanted to split sections. So sometimes I will separate my code into like chapters in a sense, and I'll do these big blocks and things. It's not even necessary. Some people code without ever using these. Some people put these things in everything. So some people with these header comments here will do this kind of thing. I don't know if that lines up. And the rest, it's going to take me ages to do it, but the rest of them, they put a whole box around things. So those ones, in a sense, don't need to be indented because they've got their own massive, slightly over-engineered information there. But these ones, especially if they're referring to a line, should always be indented to the line they're referring to, and if they're inside curly brackets, they should maintain that indentation. Because if I did something like this is super confusing, right? Because then everyone's going to think the while loop ends here because the indentation's gone back out. So we do need to remember that the indentation is how we as humans track whether we're inside or whether we're leaving or inside curly brackets. So if the comments suggest that we may have left the curly brackets, it's going to confuse people. So we keep it at the same level. Okay, I should wrap this up soon. Yeah, and Blake was saying that, like, we're talking about the word addition thing there. That, yeah, if we have arrays of things called strings, which I'll teach you later, then word addition gets very easy. Brendan, VS Code superior. VS Code is a very useful code editor. I use it for a lot of other things. When we're, again, this is the same thing as like 1511 when we're talking about for loops and we're talking about switch statements and stuff like that. It's not like I haven't used all of those in professional programming, but when we want the easiest path in, gedit is a very nice, easy path in because it doesn't have all the bells and whistles that something like VS Code has, because the more features something has, the more stuff it has to confuse people who have never seen things like this before. I have actually taught beginner programming courses where we started in VS Code, and a lot of it is just kind of like, please ignore 3/4 of this program, and we're only going to use this bit, and I will slowly teach you about these other parts. Which is why I like something like gedit, because like everything that it does, like cut, copy, paste and stuff, are things that people have seen before. The only things it adds is like line numbers and syntax highlighting and stuff, so it's kind of like, you know, the same like that. Yes, Blake is saying opening Photoshop for the first time. So I had friends who taught that because I used to teach in computer game stuff, and so they would teach Maya and Photoshop to beginners. I always laughed when they did that because I was just like, what do you do? How do you try to hide like the 18,000 buttons that are in these programs? And it's like, no, we can't, because we can't change the layout. We have to give them the default layout and teach them with that. We have to just tell them not to look at things. It's like, that's tough. Okay. Ooh. Stefner is saying that your code output was wrong according to autotest, but it was exactly the same as the reference slide file. That's something to send through to us, definitely, because that might mean that our auto tests are not up to date to the reference. So that could be a bug, because our auto tests, a lot of those are handwritten, and so someone could have just made a typo in the auto test for what it's checking. A lot of the time when we create the auto tests, we will actually go run it in the reference solution, then copy paste the reference solution to be like, okay, this is what the people should be doing. But obviously mistakes can be made there. So Evan said they've made a post about that. Yeah. Blake had to teach their year 9 teacher Photoshop. I guess it depends, because there's not, like, in terms of your high school teachers, there's not necessarily a reason why they would have to know Photoshop. Okay, looks like I've caught up with chat now, and there's no more questions. We've gone through the code, looked at a lot of different things here. So I will wrap up the stream here, and I will see whoever's coming to look at the assignment tomorrow at 4. I'm going to have Tom in with us, Tom the subject admin, because he's been doing a lot of the editing of the nitty-gritty for the assignments. When I talk about the wide ideas of what's in the assignment, he's going to say it's actually built like this and stuff, and so we'll bounce back and forth on those things. So see some of you tomorrow, and everyone else, I'll see you on Friday for our normal lecture, 4 to 6 p.m. See you later.